familiar? So that opening is called, okay, so let me give the name. It's called the pupil. So pupil is the opening of the eyes. It's a tiny hole, okay, very, very tiny hole or passage. Now we have the same in camera, and we are referring to these openings, okay? So we call this opening as aperture, okay? Next, now we also have this part in the camera which is responsible for the refraction of light. Refraction of light is very important in our eyes so that the image will be focused. Okay, so without this part, okay, so the light will not be able to be bent as it enters your eyes for focusing. Okay, so this part is found between these two muscles. Okay, so we are referring to this part. Wait, it's hard to draw. So we have here, and it is made of a very soft tissue. Okay, it's so soft, like the texture is like a jelly. So that's how soft this part is. Okay, and we call that as, it's simply called the lens. So that's the lens of our eyes. Okay, so it's made of a very soft tissue like a jelly, which allows the refraction of light in order to focus the image. And the camera also uses lens. Okay, and where is that lens? So usually, so again, it depends on the model, huh? So usually the lens is found here, and we are using a convex lens. So this is a convex lens. Okay, so the same function to refract the light in order to focus the image. And where is the image focused? So for the human eye, the image is focused at this part where some group of cells are found, such as cones and rods. Okay, so what do you call this part of the human eye where the image is?
Retina.
Yes, that's right, Jantio. We call that the retina. Okay, and a camera has a feature that acts similar to the retina of the human eye. So we can find it here. Are you familiar with that part that functions like a retina in the
Is it a film, teacher?
Yes, that's correct, Javier. We call that the film. So this one is the film. It's like a plastic material, which is very sensitive to light. Okay, so the light, the image is registered at this part. Okay, so we call this the film, and the film is used to develop the picture. Okay. Usually we call the film as the negative. Okay, and then where the picture is to develop, so that is the like the positive output of your of the picture. Okay, so as long as you have the film, you can keep developing as many copies of the picture as possible. Okay, that's why we store the film and avoid exposing the film to light, because like what I said, it's light sensitive. And same as with retina. Retina is light sensitive. That's the reason why iris play important role in regulating the light. If if the eye receives too much brightness, what will happen to your eye? So it will damage your retina. It can cause blindness. Okay. And how about with if you don't receive any amount of light, let's say for weeks or for months, you don't receive light. what will happen to your eye?
Become
Because
very
too much,
sensitive.
the eye will become very sensitive. Or the worst is, it will also cause blindness. Okay, so not receiving light or too much amount of light can cause blindness. So that's how sensitive the retina is. Okay, so this time let's talk about some vision defects. Wait, vision defects and how we can correct uh, and their corrective lenses. So what lenses could we use to correct that defect? Okay, so there are two most common vision defects that I will introduce, but there are lots of them like cataract, stigmatism. Okay, but I will introduce the most common, which requires glasses in order to correct, so lenses or contacts. Okay, so the first is the what we called myopia. Myopia is also known as nearsightedness. Okay. And the second one is hyperopia, or also known as farsightedness. What's the difference? So from the name itself, if you are nearsighted or myopic, it means you have inability to see distant objects clearly. So you only see nearby objects clear, but when you make it farther from you, it becomes blurred. Like my case, I am myopic. So without my glasses, I cannot see far objects clearly. Okay, but even without my glasses, I can read stuffs right in front of me as long as it's closer. Okay, because I have ability to see nearby objects clearly. So that's for myopic people. Okay, if hyperopic, it's the opposite. You only see far objects clearly, but when you make the objects closer to you, you cannot see it well. So you need reading glass, like for instance, okay, in order to see nearby objects clearly. Okay, now let's focus on the physical feature of a myopic and hyperopic person. So we are referring to their eyeballs. Okay. Uh, wait, excuse me. All right, so let's go back to our screen. Wait. Wait, I think I lost my. Wait first, huh? Ah, here. Okay. So let's go back to our screen. Okay, so for the vision defects, so we are referring to the shape of the eyeball. So if the eyeball is normal or in a normal shape, so it looks like this. So this is a normal shape. Okay, but in some cases there are eyeballs that are like elongated, like this one, and some are shortened like this. So which it has elongated eyeball? Is it myopic or hyperopic? Okay, it's a myopic person with elongated eyeball, whereas a hyperopic person has shortened eyeball. Okay, so that's the difference. Okay, elongated, this one is quite shortened. All right, now let's say this is the image, the object. Okay, now let's say for a myopic person who is nearsighted, we want to put the object from a distance. Okay, so if we make it far from the eyeball, what will happen to the image when the object is far from a myopic person? So we expect the image to be refracted like this. So when the light from the object is reflected and enters the eye, so the lens will refract the light, and the light will appear, or I mean the image will appear here. By the way, the image form is inverted. Okay. So where is the image focused? Is it right at the retina, in front of the retina, or behind the retina?
In front.
So it's in front, okay? Because of the shape of the eyeball, it tends to focus the image in front of the retina, okay? But if it's in a normal shape, it is expected to be focused exactly at the retina, okay? So not in the case of myopic person. So what lens could be used uh, in order to correct this? So what lens are we going to use? Are we going to use concave or convex lens?
Concave.
Concave.
Lens. Okay, yes, we will be using a concave lens. Now, what does the concave lens do with the image? So let's. Oh, I don't have picture of concave lens. Wait, So let's try using concave lens. So what does the concave lens do with light? So this is a concave lens. So when the light is reflected by the distant object, so this one, what does the concave lens do with the light? So the concave lens will diverge the light. Okay, now diverging the light will allow the refraction in a myopic person with elongated eyeball to be focused exactly at the retina. Okay, so that is the role of a concave lens. Okay, to diverge the light, allowing the refraction in the lens of the eye of an elongated eyeball to be focused exactly at the retina. So it depends on the thickness of your eye. So that's why it has to be measured when you are doing eye inspection. Okay, when you are purchasing glasses. All right, now let's go to a shortened eyeball for farsightedness. So again, if you are farsighted, you only see far objects clearly. But what if we put the object close to a hyperopic person? So if it's close to hyperopic person, where do you think the image will be focused? Do you think it will be focused in front of the retina, at the retina, or behind?
Behind.
Yes, it will be focused behind. That is because of the shorter shape of the eyeball. So you will see the image blurred when even the object is close to you. Okay. So how do we correct that? So in this case, we are going to use convex lens. Okay, so use a convex lens. So let me copy image of a convex lens. All right. Oh, wait. Here. Okay, so we use convex lens to correct it. What does the convex lens do with the light ray?
It converts
Let's
it.
say it converges the light. So the light is converged And this converging of light ray will allow this light being refracted by the lens of the shortened eye to be focused exactly at the retina. Okay, and correcting your vision. All right, so do you have any question regarding the anatomy of the eye compared to camera and their defects, corrective lenses? Okay, so that's all for today, and I think this will be the last topic that we will be discussing in optics. So by next meetings, we will move to a new chapter. Okay, so you may now proceed to your next subject. Goodbye, class.
Okay, goodbye and thank you, teacher.
Good day.
Goodbye, thank you, teacher.
Goodbye,
All
thank
right.
you.